Welcome to the project demonstration of solar light pole with MPPT and solar tracking system using PIC microcontroller. So the main application of this project is we have the solar tracking system which is used to follow the sun when sun moving from east to west to get the maximum power, means maximum sunlight on this solar panel. And the next feature is, as we are using the 12 volt solar panel, so it can generate up to maximum voltage of 18.5 volts and open circuit voltage is 21 volts. In order to maintain the maximum power, the system will regulate that voltage to 14.5. So why? Because so we are using the 10 watt solar panel. So in order to maintain the power, so 12 volt 10 watt solar panel and the current, so the power equal to VI, and whenever the 10 watt is getting maximum power, the voltage should be 14.5 and respective current should be around mentioned current. And if the voltage increases, in order to maintain the power constant, then the current will be decreased, so that the system can't provide the maximum current to charge a battery. The current also is a main parameter to make the battery fully charged in less time. So in order to get the maximum current with maximum power, and the system will regulate the voltage, restrict that to 14.5 volts. So that is called the MPPT, and that will be achieved by our microcontroller continuously, which will measure the voltages by using the voltage sensors. So inside this box we are using the two voltage sensors. This is the voltage sensor of 10:1 potential divider ratio, and this is also 10:1, means we are using the 10 kilo ohm and 1 kilo ohm as a potential divider, so that the voltage will be divided in 10:1 ratio. Means if the solar panel voltage is 15 volts for example, then the output of this voltage sensor is a 1.5 volts, as we are using the potential divider, so that the microcontroller can easily measure 1.5 volts, and in the programming we will multiply that with the 10, as we are using the potential divider of 10:1. So in that manner we are going to measuring the voltages, and when it crosses the 14.5 volts, then the system will start controlling that using MPPT, using this with the help of this MOSFET. Means here you can see the solar panel voltage, so which is coming from here, and that is parallelly input to this charging circuits. The output of the charging circuit is input to the MOSFET, and this is MPPT purpose, and the MOSFET output is connected to the battery pack directly, and parallelly we are providing that voltage to this voltage sensor. Means a closed loop manner, continuously measuring the voltage, and based on the voltage input it will regulate the pulse width signals to this MOSFET that will be displayed on the LCD screen. This is the MPPT. Next, solar tracking. Using this with the help of these two LDRs, the system will place the sun position. Means when he is moving towards the west side, then this LDR will get the more lighting than this one, so that in order to get the main same sun lighting on these two LDRs, the system will keep on rotating this DC motor with the help of this L298 motor driver. So that is used to drive this DC motor when the sun is moving towards the west side. So the system always keep this solar panel perpendicular to the sunlights in order to get the more lighting to get the maximum voltage. This is the third feature, and the fourth feature is third feature is the second feature. Third feature is, in order to control this street lights, we are using the another LDR which is used to detect the sun lighting and day and night mode. So in the night modes, then there is no lighting on this LDR sensor, the light will get switched on. In the day mode, the sunlight will be detected and the light will be off. So these are the main three features: solar tracking, MPPT, and headlight street light controlling system. And we are using the ratings of 12 volt 10 watt solar panel and 12 volt 7 amp DC battery pack we are using, and these two relays. One relay will allow the power supply to the battery whenever the battery voltage is low, means charge controller purpose. Another relay to control the street light, and this is a charging circuit just to get the power supply input to the voltage sensor and to the MOSFET, as it is acting as a unidirectional current flow. Whenever the battery is fully charged, these diodes will block the current flow from the battery to the solar panel, and whenever the sunlight is less on the solar panels. So let us check with the demonstration. So just when we on this power supply, the welcome message will be displayed on LCD. We can see the BV nothing but battery voltage and solar panel voltage, and next is a day mode, and PWM signal is -3 as we are getting the less voltage. So in the night mode, the light will get switched on. You can see the M nothing but mode nothing but night, and day mode. Okay. And coming to the tracking. Right. So it's locks over there. Just keep on rotating that side. So for user friendly, we keep this anti-clockwise rotation also for easy demonstration purpose. In real time, it's keep on following the sun when sun moving from east to west. So like this. And back won't happens, but for demonstration easy purpose we kept this condition. Right. Okay. And coming to the MPPT, while we place the more lighting on this solar panel, the voltage will be increased. So when it crosses the 14.5 volts in real time, directly we are going to get the PWM signal will be increased. Means PWM, but pulse width modulation will be increased here. And you can see the lighting placed. So we are getting the maximum voltage, and the brightness of this LED will be increased. Thank you.